All right, Ryan, let's go down to number 11. If you need help, Ryan, on the phase shift and the period, I'll come back, okay? I'll come back and just help you. All right, let's go to number 11. Y equals A sine KX plus C plus D. All right, y'all look at number 11. The amplitude goes in the front, and automatically the location change goes in the back. That's how you start it. Go ahead and write that down, Destiny. All right, that's the first step. Silas, you got that written down? All right, Silas, do you remember how we find what number goes here?
Would you have 2 pi over k?
Okay, we got 2 pi over k is our formula, and what I set that equal to?
Would it be pi over 2?
Yep, the pi. Yeah, the formula. I'm sorry, the answer they give you for the period, which is pi over 2. So you guys take 15 seconds, cross multiply that, and divide it, Blake. Let's see what you get. Yeah. Hey, why don't you pass them out for me, Ella? Give everybody one, please. Ella's gonna walk around and let y'all get a color pencil. All right, so when I cross multiply, I got pi and k, and I got 4 pi. So Silas, what do I divide by?
Would it be pi over k?
You always divide by what's with the k. So I got to divide by pi. So my answer is 4. So look, right here I put 4x in that spot. Check my work for me off everyone you do. All right, we good on that, Silas?
We're good.
All right, now Silas, do you remember how to find that number?
Would it be 4x and 4 pi?
All right, so I take what they give me for phase shift, which is 4 pi over 1, and I set that equal to negative c over k, because that's my formula off my formula sheet. But
for k, you have
k is 4. Good. All right, Silas, cross multiply and divide that and see what you get. Now, so even if you guys are done with number 11, go back and let's check your work, make sure you got the right answer. All right, Silas, when I get to here, what number do I divide by?
it would do 16, 11, or would it be 1?
You always divide by the number that's with the letter. That's how you know.
All right.
So I divide by negative 1. My answer is going to be negative 16 pi. All right, so Ryan, any question there? Understand that one? Destiny, you can do that? Jacob, you got any questions? You might have saw some of that, Jacob, before you got out. Okay. Christian, you still good on that? It's number 11. Yeah, all of it's just cross multiplying. All right, well, watch me on 12 then if you got a question.
That's what I'm looking at.
Okay. All right, I'm erasing 11. Silas, go to 12. Y'all go ahead and set it up. All right, so number 12, we got 10 is the amplitude, and location change is 4. All right, Ryan, can you walk me through how do I find this number right here? What do I set up so I can cross multiply?
Pi over 1
Good.
equals to 2 pi over k.
Very good, Ryan. Cross multiply that and tell me what you get.
2 pi is equal to pi k. I don't know.
Okay, Ryan, that's good. Now, you always divide by the number that's with the letter. The only letter up here is k. That means I got to divide by pi. Pi's cancel out, Ryan. What am I left with? 2. So my answer in that spot is 2x. Very good. All right, Ryan, you were good on that one. Can you tell me how to find this number?
You said pi over 4 equal to negative c over 2.
Very good. All right. Try to cross multiply and divide it and get your answer. You don't have to do it in your head, Ryan. You can write some down. So 2 times pi, negative 4 and c. So Ryan, what number do I divide by? Very good. 2 over 4 is going to be negative 1/2. So it's negative 1 over 2 pi. Y'all could also write negative pi over 2 if you wanted to. I would accept either one on that. All right, Christian, any question on that one? Got it? Okay. All right, so Christian, when you flip it over, what's going to be the only change on 13 and 14? Yeah, instead of sine right here, it's going to have cosine right there. So I'm going to stop and give y'all a second to try 13 and 14 before we start doing the graphs. You guys who were out, I got a lot of graph sheets for y'all to work on. Alright, so 13 will be 2 cosine up 4. Alright, I'm going to stop right here and let y'all work on this for a minute. Alright, everybody good? Through those. Now, those were the ones that we did the most. Alright, so Christian and Jacob, we're doing new stuff now in 15, so I will slow down. Do I have, yeah, I got a graph up here that y'all are jealous of somewhere.
Yeah, you said you was gonna fix our graphs and then.
I might have lied on that one, Michaela.
Did you fix them for the quiz?
I might have lied on that one. I said I was going to fix it for next year, I think is what I
No, you
said.
said
You
you
said
was
you were
gonna
gonna
fix
fix them
it.
for the
You
test.
said
Maybe I have to fix it for next year. Guys, I had that time. I've been busy.
I think you just need to give us some graphing paper.
Dude, I think we graph
Hey, I will check and see if I can find some graphic paper on
You
this.
just throw
Deal.
the graphs out,
Okay,
that's
graphic
fine.
paper.
I will check and see if anybody has graphic paper on this.
If not, the
Mr.
graph should
Fred.
count against us. Because we can't see it.
We'll all find some graphic paper.
We're not good at this one.
All right. All right, Jacob and Christian, if I lose you, let me know. The problem says y equals 3 sine x. All right, Jacob, Christian, if you look in the instructions, it says graph the base graph for each problem first. What that means is just plain old sine x. That's the base problem. That means that's where you start. It's the standard problem. So we're going to have to graph that first. And Christian and Jacob, y'all got to just memorize what that looks like. All right? It starts at 0, goes to 1. That's what a sine wave looks like. All right? So Christian and Jacob, y'all got to memorize that. All right, Jacob, now they want us to look at the problem they gave us, which is this, 3 sine x. And we got to look and find our 4 answers first, and then we'll see if any of these answers have changed from the original sine x problem. So Jacob, what's my amplitude going to be on this one? Period.
Are you gonna
2 pi over 1, which is 2 pi. How do I know there's not a phase shift? Good.
are you gonna be judgmental on the things? The graph, the lines? 'Cause that's the-
People who are special that can't draw those graphs, I'll try to take that under consideration.
Well, I'm one of those people.
You ain't as bad as Michaela. She's the worst I've seen in 25 years.
What's your graph look like?
All right, so let me explain something, Christian.
I
Jacob,
do it even.
do you see it starts here and it gets back to where it started? Oh, I did mess up. Why didn't you say something?
Yeah, I was about to say, looks like yours was.
It gets back to there. My bad. My bad.
Well, I
So-
thought I did it wrong.
Jacob, you should have 3 dots on the x-axis. I don't know what I was. It's Monday, guys. I'm struggling. All right. So Jacob, when it starts at 0 and it gets back to here, it starts over. So by getting back to here, it is gone. You could say 1 cycle or 1 period. The length it has to go to get back to where it starts is 2 pi. Okay, well look, originally the first one, that was the period anyway. So that hasn't changed.
That stops at 2 pi.
Yeah, the only thing we're going to have to change is the amplitude. All right, now watch. Here's how you do amplitude.
I swear last time we did it, it stopped at 3 pi or 2.
No. So, Jacob, you see the 3 dots on the x-axis? They never move off the x-axis. So with your color pencil, give me 3 new dots on that x-axis. Tell me when you're ready. All right, so all you have to do, Jacob, is times. Do you see this dot that went up 1? Right here, it went up 1. If you times it by 3, now it's got to go up 3. All right, and Jacob, do you see this dot right here that went down 1? Right here, went down 1. Yeah, so now it just goes down by 3. That's how you do an amplitude right there.
We can't really go
Christian, question.
Point's not on the axis and
That's the ones you move. The point's not on the axis. Very good. If it's on the axis, Christian, it always stays when you do amplitude.
you move it 2, 3 or up 3?
Good question. You move it up 3, but you start back at 0 and count over.
Oh, okay.
So yeah, you just go to 3. All right, that's how you do it. All right, let's do another one. All right, 16. All right, the base graph is going to be cosine x. And then they want us to graph -2 cosine x plus 3. All right, here we go. Jacob and Christian, the base graph for cosine starts at 1. Now, Jacob, first, before you write those points down, look at it. It looks like a V, right? Christian, you got to make it look like that. It's curved. It's, somebody said it looks like handlebars on a bicycle.
Where does it start?
Same place, 2 pi. So write that down for your graph for cosine. All right. Now, one thing let me show you, Christian, Jacob, if we plotted more dots, it goes on and on and on. I mean, that sign would be the same thing. It's just been slid over. Let me show you what I mean. Jacob, if I grab this red one of sine and slid it over, it matches up with cosine. The only difference is it doesn't start in the same spot. Okay? All right. So now, Christian, let's go through and let's find our new answers for the problem they want us to graph. All right. On this one, Christian, what's my amplitude? Period. No phase shift, but my location changes up 3. All right. Write those new answers down. All right. Jacob, I'll wait on you. Ready? All right. Remember, Jacob, if the new period is 2 pi, that's the same as the old period because that's how long it was to start with. So we don't have to change anything there. The only ones we got to change are these 2. Now, you guys who were here last week, when I got more than one thing I got to change, where do I start? Start in the back, Silas, and work your way to the front. All right, so this is what I mean. We got to go up 3 first, Jacob. All right, that's going to be just like moving it up. 1, 2, 3. The whole thing, you're just going to slide the whole thing up 3. So I'm going to put it in red. 1, 2, 3. All right, that's what it looks like. I just moved the whole thing up 3. Now, the other thing I want y'all to do, about half of y'all didn't like to do this, and that's fine. Jacob, when you have to move up 3, our x-axis used to be at 0. Now it's at 3. I want you to put an imaginary dotted line right there. That's going to help us when we have to do our amplitude on the next step. All right, any question about the first step? I just moved up 3. All right, so now, Jacob, we do the amplitude. All right, which means, I'll wait on you, I don't want to lose you. All right, I only got one more thing, Christian, I got to change. What happens with the dots that are on that x-axis right there? They don't go anywhere. You leave them, Jacob. The other ones are the only ones that you move. So, Christian, now I got to go up 2. Instead of going up 1, I go up 2. I go down 2 there. That's your new amplitude. That's your new graph.
How do you get this?
Yes, sir. That's why I wrote my dotted line.
How do you get the period?
The formula is 2 pi over k, Gracie. K is the number in front of x, so I did 2 pi over 1, so it stayed 2 pi. You can use your formula sheet, Gracie, if you need to. All right, 16. We're good? All right, Jacob, let's go to 17. Now, Jacob, you should be able to go ahead and do the first graph by yourself. All All right, look back and see what we did on the other one. See what it looks like. Sine x, I go here, 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 here. There it is. All right, so now Jacob and Christian, I want y'all to find the 4 new answers for this, and I'll wait on you. All right, Madison, what's my new amplitude? I'm on 17, 1/2, period. No phase shift, no location change. All right, good. Christian, good. All right, so Christian, this is the first time we have a change now on the period. All right, how long is a normal period? 2 pi. So now, Jacob, they want us to draw the same shape, but they want us to stop at 1 pi. So instead of it going all the way to there, it's got to go right to here. So I'm going to, I think last week everybody said compress it, squeeze it. I'm going to start it in the same spot. Christian, after that, I'm going to squeeze it into half the distance. So it's going to look something like that. And that's the one nobody likes. I think that's the hardest one to understand. I think the phase shift is pretty easy. You're just sliding it. I think that's the hardest one.
Are we turning this paper in?
I hadn't thought about
But I
it.
can't get number 16.
Amplitude. Guys, I don't like doing an amplitude of 1/2. But let's go ahead and do it. All right, somebody help me. If my amplitude is 1/2, yeah. Well, first of all, these all stay on the x-axis, and then I just go up. This is going to be very hard. Half the distance there and there. Yeah. So my answer is the red one, guys. Yeah, I'm never going to get y'all a fraction on the amplitude again. That's crazy.
Stay back and back.
We're going to do one more problem, and we're in a bathroom break.
I need some standing up.
Yes, you do. You're asleep this morning. All right, we got one more, and then we'll go to break. All right, 18. First thing we got to do is write cosine x. Remember, that looks like handlebars, Jacob. Why I can't get going today.
And you said how many of these are going to be on this?
4.
Okay.
So we're making a change. The test is going to be in the morning. We're going to give y'all another time after break when we can work on these graphs. All right, Christian, give me my 4 new. Oh, let me write it down first, Christian. 3 cosine 2x minus pi minus 1. All right, Christian, give me my 4 new answers. What's amplitude?
3.
Period. Phase shift. All right, remember the shortcut. Flip the sign on this one, Christian. That goes on top, so that'd be pi on top. Pi over 2. Location change down 1. All right, I didn't even give us one like this last week, guys. There's 4 things that change on this one. I've never gave us anything more than 3. All right, so Jacob, when you have more than one thing that change, where do we start? Start in the back. So I got to go down 1. So like I showed y'all, dotted line and then move every point down 1. All right, first one's done. Just slid everything down 1. All right. Next, Jacob. You ready? I'll wait. All right, next says phase shift. Now look, all you got to do on phase shift is grab it and either slide it this way or slide it that way. That's all you got to do. All right? it says to slide it over and start it now, Christian, at pi over 2. Where's that at? Where's pi over 2? It's over one spot, right? So all you got to do, Christian, take it, slide it over. You'll just have to draw a new one. I can just slide it over on mine.
Yeah.
Is it okay if I just leave that, or do y'all want me to draw it?
Draw it.
Draw it? Okay, I'll draw it. Oh no, I messed it up. All right, so if I move it over one spot, it's there, 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 there. All right, Christian, any question there? I just slid it over. All right, third thing we got to do. Man, this is going to get messy. All right, now let me explain something on this one. All right, Jacob, we got to make the period, instead of 2 pi, we got to squeeze it into 1 pi. Well, look, normally, let me get this graph up here.
Are we gonna write this on the test?
Not with 4 changes. This is way too much. Normally, it goes 1, 2, 3, 4 spaces is 2 pi. Well, how many spaces do you have to go for it to be 1 pi? 2 spaces. Okay? So that's what we're going to do. We're going to squeeze this into 2 spaces. I start it here. I got to end it there. So I go down, 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 down. There we go. All right, last is the amplitude. Yeah, I should never give y'all one with 4 changes. This gets too messy. Amplitude, remember, Jacob, the ones on the x-axis stay. I got to go up 3 now. So 1, 2, 3. 1, 2, 3. All right, let's go to break.
No.